right, we've finished section 7.1 about angles and applications of angles. So now it's time to really begin trigonometry, okay? Trigonometry can be approached in one of two ways. We can either approach it from a triangle perspective or a circle perspective. And as a teacher, you kind of have to choose which perspective are you going to present first. The textbook kind of set it up so that you could do it either way, but the order of the sections is triangles first, circles second. And I've taught this both ways, and in my opinion, the more intuitive approach is triangles first, circles second. A lot of my fellow teachers disagree with me about that, but I'm going to go with, I'm going to present to you the triangle perspective, and then we'll do the circles perspective. And in the long run, I will admit that the circles perspective is deeper and more lasting and like more important, I think, when it comes to trigonometry. Trigonometry is admittedly more about circles than it is about triangles. But I think the triangles approach as an initial exposure to trigonometric functions, I think triangles are an easier idea to wrap your head around. So we're going to start with triangles. In particular, we're going to start with right triangles. Let's draw a right triangle. A right triangle is a triangle for which one of the angles is a 90-degree angle. So there's our 90-degree angle over there. Let's choose an angle in this triangle that's not the 90-degree angle, and have that be our perspective. Let's say that we are viewing this triangle from the perspective of this angle right down here, and the measure of that angle, we're going to call it t. So in a right triangle, that's got to be an acute angle, which is an angle somewhere between 0 and pi over 2, or if you're in degrees, somewhere between 0 degrees and 90 degrees. Okay. So from the perspective of that angle, the three sides of this triangle can be labeled in the following way. This side here, which is one of the two legs, is called the adjacent leg. So we'll call that the adjacent side of the triangle. The other leg of the triangle is the opposite side. And then there's, of course, the hypotenuse of the triangle, which is unique and special. Hypotenuse. So we have adjacent, opposite, and hypotenuse. I'm going to abbreviate those three things as ADJ for adjacent, OPP for opposite, and HYP for hypotenuse. Okay, let's have those abbreviations represent the measures of those three sides. So like the lengths of those three sides. Trigonometric functions are defined as ratios of those sides. So there's three main trigonometric functions we're going to start with. Later we're going to establish three more, and there actually exist lots of different trigonometric functions. But the three that we're going to start with are sine, cosine, and tangent. So sine, and I should state, these are all functions, all right? So in the same way that like you write f of x or ln of x, when I write sin, which abbreviates sine, and then parentheses t, the parentheses here mean this is the input for the function, okay? It's just like any other function where it's the input. So please don't mistake sin as representing a variable or a number. It's not, it's the name of a function. Okay, and the parentheses there does not denote multiplying, it denotes function input. So trig functions are functions that take an angle value as an input and give you some number as an output. And the output of that number is determined by the ratio of the sides of a triangle that involves that angle. So if we have an angle in a triangle, the sine of that angle is given by the opposite side length divided by the hypotenuse side length, like that. Opposite divided by hypotenuse. The cosine of that angle, which is abbreviated COS, is given by the adjacent side length divided by the hypotenuse. And then the tangent, which is TAN, the tangent of that angle is the opposite side length divided by the adjacent side length. And there's a really famous like mnemonic to help you remember this. It's called SOHCAHTOA. It goes like that. SOHCAHTOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So if you remember SOHCAHTOA, then that helps you remember the ratios that define these three trig functions for an angle in a right triangle. Now, one of the questions is, well, how do I know that that ratio is always going to be the same? Because you could put this angle in a different triangle. Let's say take the exact same angle here, T. It's exactly the same angle, but let's put it in like a little itsy bitsy triangle. Okay. Well, now the opposite side and the adjacent side and the hypotenuse length, those are all different lengths, right? That triangle is tiny by comparison. So how do I know that the ratio is going to be the same? Well, the way you know the ratio is going to be the same is that this and this, these triangles are similar. Similar triangles. We know for sure they're similar because they both share a right angle and they both share another angle. So the third angle has to be the same as well because the angles have to all add up to 180 degrees, which is a fact you may remember from geometry. So if they have the same angles, they have to be similar to each other. And if they're similar, one of the facts from geometry, again, is that ratios of corresponding sides will be constant. So the outputs of these trigonometric functions are not dependent on the particular triangle you're looking at. As long as you have a right triangle that contains the angle t, then no matter which triangle it is, that ratio will always give you the same output value. So these are what we call well-defined. They always give you the same value no matter how you calculate them. That's because of geometry. So now that we have these three functions defined, let's look at an example where we're going to use one of them. Let's look at an example where we're going to calculate the values of these three functions for a particular triangle. Here's a triangle, a right triangle, and here's our t again. Let's say in this case, the sides of the triangle are 12 centimeters, 5 centimeters, and 13 centimeters. I can't just randomly write down different numbers here, okay? I can't just randomly write down numbers for the three sides because it has to satisfy the Pythagorean theorem. Remember, the Pythagorean theorem says a squared plus b squared has to equal c squared, where a and b are the legs and c is the hypotenuse. And in this case, it's 12 squared plus 5 squared equals 13 squared. In this triangle, that is correct. That works. So I chose these numbers because these form what is called a Pythagorean triple. So now with this triangle, we can calculate the sine of the angle t. The sine of t is the opposite divided by hypotenuse, which is going to be 5 centimeters divided by 13 centimeters. You notice the unit cancels out, and we get 5 over 13. So the output of a trigonometric function is a number, which is again unitless, kind of like radians. So here is an important point to remember. Trig function outputs are unitless. Okay, the cosine of this angle t will be the adjacent divided by the hypotenuse, so that's 12 centimeters over 13 centimeters, or just 12 over 13. And then the tangent of this angle t is opposite, which is 5 centimeters, divided by adjacent, which is 12 centimeters, or 5/13.